Hello everyone and welcome to your explanation for worksheet 3B. This is in week 5. We're in unit 3 and this is for college trig MAT122. So what we're going to be doing on this worksheet is graphing more of the trig functions, but mostly we're going to be focusing on sine and cosine. And what we're going to be talking about on this worksheet specifically is transformation, so how to move these graphs left, right, up, down, flip them, stretch them, all of these types of things. So if we look at this, looking at this generalized formula on how to transform these, we have, it's real similar to when we were transforming parent functions like quadratics and absolute values and things like this. We'll start with the A. So the A out front, once again, is going to change the amplitude. So in this case, A is going to determine how high your wave goes and how low your wave goes. So if you have an amplitude of, let's say, 3 was where that A is, that would make the wave, wherever the center line of your wave was, it would go up 3 from that and down 3 from that. So a typical sine curve is centered on the x-axis, so it goes up 1, down 1. So a normal sine curve has an amplitude of 1. Like I said, the way we change that amplitude is with that A out front. Okay, I'm going to skip K for now because that's the most complicated one. But let's talk about C. C, just like our parent functions, it's inside the parentheses, and it's going to shift it left and right, and once again, it's going to be opposite. So if you have a sine curve and it's starting at 0, 0, to shift it to the right, you would put minus something, so -5, -2 pi, something like this. So that one's just your horizontal shift. The D is very, very simple. It's just your vertical shift. So if it's +5, you move the whole graph up 5 units. If it's -10, you move it down 10. So that one's real straightforward. Now the K is by far the most difficult to understand, I think. K doesn't really tell you anything on its own. What we have to do is we have to take the K, whatever it is on the outside of the parentheses, and we have to divide 2 pi by it. So if we factor out, like, let's say it's pi, and then K for us is a pi. We take that, we divide 2 pi by pi, the pi's would cancel off, and the period would be 2. Period is telling you how long it takes for it to do a full cycle. So if you look up at the picture, it's measuring from the top of the wave to the next top of the wave. So the wave went down, it reached the lowest point, and it went all the way up back to the top. So it's doing a full cycle. So you can think of period as a full cycle, or how long it takes to repeat itself. So this is the generalized formula. I would take a picture of this or have this written down somewhere, because this is going to be extremely important to remember as we're going through these examples. Now, I did put one picture in here of what different amplitudes look like. So just as an example, so the F of X is just the black line. So the black line is just your normal sine curve, and it's, it looks like it's meant to. The 0.5, like I said, it's going to take all your waves and make them only go up half as much as they normally do. So that's the red line. And so it's going up a half, down a half, up a half, down a half. And the waves, as you can see when they're compared to the black line, are half as much. The blue line is if you had a 2 for your amplitude. So these ones are going to go up 2, down 2, up 2, down 2. And all of these curves, we didn't change the period, we didn't change the horizontal or vertical shifts. So they're all crossing the x-axis at the exact same points. It's just they have more of a wave to them. So they're a little bit higher, a little bit lower. Okay, so instead of jumping straight into some problems, let's look at a couple examples that I usually have. So for the first one here, this is example 1, and all I did is on a graphing calculator, I graphed sine of x, and just very, very normal. Now, to get these tick marks where I have them, my y-axis is going from +4 to -4 and counting by ones, and that's why there's little tick marks where they're at, and that's why the 1 matches up with where it's at. And now the x-axis, I went from -2 pi to +2 pi. So on your calculator, when it says x minimum, just put -2 and then the pi button, and it'll turn it into a decimal for you. And then for x maximum, you just say 2 pi, and that will be the maximum. Now, the scale on this, to get a tick mark exactly halfway in between, I had to do pi divided by 2, and that's why there's a tick mark right in between and right where it crosses. So my x scale is what it is pi divided by 2. So that's how I got this exact graph. Now, on this one, I graphed the same graph I had on the last slide. So it still has the sign of x, and that's the lower one. And then the second one, I just did sine of, or 3 times sine of x. So an amplitude of 3, so it's going up 3, down 3. So it's going up higher and down lower. So the amplitude is the only thing changed here. Now on the next one, what I did is I have my normal sine curve again, but on this one I put a -4 out front. Now the negative, just like you would guess, flips it, so instead of going up immediately, it goes down first and then up. And then the amplitude on this is 4, so it's going down 4 first, up 4, down 4, up 4. So that's what this looks like if you have a negative amplitude. Now this one's real interesting. I put a 3 in front of the x. So that 3 is your k in our generalized example. So if I divide 2 pi by 3, 2 pi divided by 3 doesn't, you can't really simplify that much. So what this is doing is this has a period of 2/3 of a pi. So it goes up, it goes down, and then comes back up again. And so where this graph is doing a full cycle, that's 2/3 of a pi. And it looks like it's 2/3 of that pi. So this is what it looks like when you change the period, or what it can look like. Now, on this slide, on the top one, I have a sine of x, just normal sine of x. Second one, I changed what did I do on this one? Oh, I guess I just changed the period. So yeah. So it's doing a full cycle, and it's doing a full cycle within 2/3 of a pi. So that one's just the period has been adjusted. And then down at the bottom, I'm showing how I changed my scale. So the first one is counting by half pies. The second one, I didn't adjust the scale. And now to make the scale more useful on the third one, what I did is I went from -2 pi to +2 pi, just like we did before. This one, the scale gets changed. So now it's having a tick mark for every 1. So this is doing a full cycle within 4. So the period on this is 4 units. So that's why the tick marks are in the right spot for this one. Okay, so for this one, I just wanted to show how crazy you could make the period. So this one, I put a 3 pi for my k. So if you divide 2 pi divided by 3 pi, pi's will cancel off and you'll get 2/3. So this one's doing a full cycle within 2/3 of a unit. Well, this scale, or my x-axis, is going all the way up to about 6.28 or 2 pi. So there's a lot of 2/3 that fit in there, and that's why there's so many little waves in here. Okay, so this whole worksheet is all about manipulating our graphs and transforming them and things like this. So let's look at an example that's straight off your worksheet. All right, so number 1, we're going from 0 to 4 pi. So we're not going to have anything in the negative direction, so that's why it's blank over there. And on the right side, we got to get to 4 pi. We got to include all the units. So what I did is I counted by half pies. I didn't write every single one. I skipped one. So I went from 0, then pi, 2 pi, 3 pi, 4 pi, and they all fit on there. And then I knew that my amplitude was going to be 2 by looking at the equation. So I wanted to make sure I went all the way up to 2 and then down to -2. And that's exactly what I've done here. Now, it's starting off by going down because it's negative, it's been flipped. And on this one, we know the amplitude is -2 and the period is 2 pi because there is no difference. There's no period shift on this one because there's no k. So it's going to do a full cycle within 2 units, or 2 pi. So that's why it's crossing at 2 pi and then again at 4 pi. So we have all this. We go down first. Our trough is at half a pi. Then we cross at pi, and then our max is at 1.5 pi, and so there we are, and it gets us back to 2 pi, and then we just do the same thing over again. So that is number 1. All right, next one. Let's look at number 4. So number 4, the only modification we're making to a sine curve on this is we're going to be changing the period. So if you notice, this one wants us to graph it from 0 to 4, so we don't have to deal with any type of radian measure on this. So I just counted by halves, so to make sure I had space for all 4. That's how I set up the x-axis, and then this doesn't have a different amplitude on it, so it's just going to go up to 1 and down to -1. So to figure out what the actual period is, what I did is I took the pi divided by 2 multiplying by the x, and I'm dividing 2 pi by it, like we're meant to do. So if you do that, you're going to end up getting 2 pi over 1 times 2 over pi. The pi's will cancel off. 2 times 2 is the 4, and the 1 on bottom is just going to stay on the bottom, so 4 divided by 1 is just 4. So our period is going to be 4, so it's going to do a full cycle within 4 units. And that makes it really convenient since our graph goes from 0 to 4, so it's going to do 1 cycle. So amplitude is 1, we didn't change that, and the period on this is 4, and that's how I got this graph. All right, so let's look at number 8. Number 8, there's a lot of modifications here. There's the 2 out front, and it's important to recognize that 2 out front is the vertical shift. So typically that's at the end, but in this case they put it at the front, which who knows why, but that's where they put it. We have a -1/4 multiplying times the sign, so that's going to change our amplitude, and it's going to flip it because it's negative. And then we also have something happening to that x. So this one is going to have a different period. So I set up the scale. I went from 0 to 4 pi, and then 0 to -4 pi on the left side. I know my amplitude is only going to go up 1/4. So I know it's going to be, a half of a half. So I counted by halves on my y-axis, and that's why it's halfway in between those squares. And now, it's a normal sine curve, so I know it's going to start in the middle, but this one's being flipped, so it starts by going downward. Okay. So to figure out the period on this one, right now it's x divided by 2. Well, that's the same thing as 1/2 times x. So over here on the right, for period, I did 2 pi, which I always do, divided by, and I called it 1/2 because that's really what your k is in this situation. So if you do 2 pi divided by 1/2, well, that's going to turn into a 4 pi if you do the work for that. So this is going to do a full cycle in 4 pi, and that's convenient because that's all I'm counting to the left and right. So I'm going to do a full cycle left, full cycle right, and that's what I end up with. The +2 at the very beginning shifts the whole graph up 2 units, and looking at it now, I did not do this right because it should be centered on the 2 instead of a 1. So my graph is technically not right. It should have a center line at 2 instead of 1. I shifted this up 1, so this graph should be shifted up 1 more unit, and it should all be centered on that 2. But other than that, everything else looks good. So I'm going to say this again. This one is not right. The whole graph, it's right, except it should be shifted up 1 more unit because I didn't go up enough. So this one is a little off, and I'll fix that. All right, last one I'm going to do for you is number 12. It says find an equation for cosine now that's in this form, and it has this graph. So if we look at this graph, usually cosine starts up at 1 and then goes down and then back up to 1 again. This one's starting on the bottom, so we know there's a flip involved, so that's how I got the negative. We know this whole graph has been shifted up to 3 because that's my center line, and I drew the center line with that red dashed line there. So I know I'm going to have plus 3. So I put that out at the beginning like they did on the last problem. So that's the red 3. It has an amplitude of 2 because it's going up 2, down 2, up 2, down 2, and we said it's negative because it's flipped, so that's my blue negative 2. Now the hardest part here, by far, is the period. So what goes in front of that x? Well, I can look at my graph and I can see it's doing a full cycle within pi, okay? So I know that my period here is pi, so I say pi equals, and then the formula to find the period is 2 pi divided by something. Well, we don't know what that something is, so we say 2 pi divided by, and I called it b because that's what they called it in the general formula up top. And then I just solve this for b, so multiply both sides by b, and then divide by pi, so I get a 2. And that's what goes in front of the cosine, and this one is all done. Okay, so that is it for this worksheet. By far, I think the hardest thing to understand on this worksheet is the period. You always take whatever's in front of your x and then divide it by 2 pi, and that's how you figure out your period. Everything else is pretty much the same, okay? We'll talk a lot more about the phase shift on worksheet 3C. They kind of ignored that on this worksheet. But for this worksheet, they really wanted you to understand the period and then just shifts, up and down vertical shifts, and then the amplitude, and then flipping it as well. So that is it for this worksheet. I hope that was helpful. Please email me with any questions. Thanks a lot and have a nice day.